Good afternoon, everyone. Thanks for joining me. My name's Cosimo, and I'm going to talk to you about how you can use an SBOM, which stands for Software Bill of Materials, to drive your vulnerability management program. But before I get into that, let me just introduce myself. I don't know why that's showing up. There we go. So who am I? So like I said, I'm Cosimo. I'm a staff DevOps developer for a company called Owner's Box. It's a small startup based out of Kitchener. I'm a family man. I have my wife, Rita, my two daughters, Penelope and Allegra, that I love hanging out with. I'm a Sec DevOps and open source practitioner. I've been in this field for over 10 years now in various roles. And I worked in various industries, including telecommunications, automotive, embedded IoT, industrial control systems, and paid fantasy sports and gaming industries. I'm also an open source advocate. I actively contribute to open source projects and community initiatives. What I'm going to talk to you about for the next 20 minutes or so is what is an SBOM, so introduce it, and why are they becoming more and more popular? How do you generate them? What do you do with one once you have one? How can you automate some of this? And then we should have time at the end for conclusions and some questions. So first off, what is an SBOM? So it stands for Software Bill of Materials. And the easiest way to think of an SBOM is similar to what you would see on an ingredient list of the back of a cereal box. It's very rare in today's society that your software project is a pure library with no dependencies. For the most part, you're pulling in dependencies, and those are pulling in transitive dependencies. So a software bill of material is essentially a list of ingredients that make up your product, whether your product is a library or an application or a mobile app or firmware, and it goes on and on. There's two commonly used formats. One is Cyclone DX. It's from the OWASP Foundation. They run that one. Another one is SPDX. That's run by the Linux Foundation. And the output of an SBOM is machine readable. So the two most common formats are either JSON or XML. So you could read one by hand if you want to, but really it's easier just to parse your way through it to pull out the pieces of information you need. A quick timeline of how we got here and why they're becoming popular. So if we go back to 2019, 2020, there was the SolarWinds attack. SolarWinds is a fairly big company. They have a product called Orion, which is a network management system. That product was compromised and shipped to thousands of their customers, and their customers are many Fortune 500 companies and US government entities. And what this allowed is attackers to gain access to their network. And this attack went on undetected for quite some time. There was also the Colonial Pipeline ransomware attack that occurred in May 2021, where all of their data was encrypted, and it was a ransomware attack. They had to pay to get their data back. This caused fuel shortages on the eastern United States and panic buying, and it also raised awareness of our critical infrastructure is very important and has to be better protected. So we fast forward a little bit. The first big catalyst here, that's why I have kind of a star on it, was the White House Executive Order 14028, improving the nation's cybersecurity. Just last week, an even bigger one, I think, was the European Cyber Resilience Act was signed into law. And both of those acts, I'm going to go into them shortly. I'm going to skim through them very quickly. Essentially, I mean, if you want to sell to the US government or you want to sell any digital product in Europe, you need to provide an SBOM. You need to know what's in your product and make that available. And I have a couple other examples here. The FDA, the US Army, if you want to sell to them, you're going to have to provide an SBOM. And moving forward in March 2025, PCI version 4.0, so payment card infrastructure, they also have their own SBOM requirements. These are just a few smaller examples, but it is becoming more and more popular, and there's more and more industries, both private and publicly funded, that are requiring SBOMs. So if I just quickly go forward, so I did mention Executive Order 14028. There is a section in that executive order where you need to provide the purchaser, in this case the purchaser is the US government, a software bill of materials, either giving it to them directly or publishing it on a website. With this executive order, they also asked the NTIA, the National Telecommunications and Information Administration, that they need to publish what are the minimum elements that make an SBOM. And as I mentioned, just last week, I think it was on October 10th, the European Cyber Resilience Act was signed into law. And this basically says if you're selling a hardware or software product in the European Union that has a digital element, which is pretty much anything mobile apps, smartphones, laptops, firmware, smart bulbs, anything like that, you need to be able to provide an SBOM in a machine-readable, well-supported format, which is most likely either SPDX or CycloneDX. So I did mention the NTIA was tasked with coming out. What are their minimum fields required? So there shouldn't be too many surprises here, especially those top 6: supplier name, component name, version, a unique identifier, dependency relationship, and an author. With those 6 pieces of information, you can pretty much figure out what something is, and then a timestamp, so you know when this SBOM was generated. But there's so much more than this. Here's just a snapshot, I couldn't really fit them all on this slide, of the latest spec of CycloneDX, which is version 1.6. As you can see, there's dozens upon dozens of fields that could be added and are added to an SBOM. So how do you actually generate one? So I'm going to show a static demo here using a project from OOPS called the Juice Shop. The Juice Shop is a very sophisticated and insecure web server that's great for demos like this. There's many tools, both commercial and open source, that you can use to generate an SBOM. This is just a very small list of some of the more well-known open source ones. I'm going to use this first one on the list, the CycloneDX NPM Gen tool, because the Juice Shop project is a Node NPM-based project. So I have this installed on my laptop here. So it's a pretty simple command. My CycloneDX NPM is installed. I want to tell it what output file to write to. I want to give it the spec version, in this case 1.6, and I need to point it to my source code. In this case, I want to point it to my package.json file. You could also point it to your build artifacts. This is going to be a source SBOM, but you could also point it to your final build artifacts, and it could pull out information from there or anything in between. So after this command runs, and it only takes a few seconds to run, I do have my SBOM generated there. Take note that it's 4 megabytes in size, so it's fairly large. There's quite a bit of information that goes into these, and we could just parse through one now fairly quickly. So these are the first 10, 15 lines of the SBOM. What I have circled is just one of those minimum elements. A timestamp is required, but there's a lot of other key pieces of information here. For example, the BOM format, in this case it's CycloneDX, the spec version 1.6. What tool was used to generate this SBOM? In this case, it's CycloneDX NPM version 1.19.3. What component did I just scan? So there's the component section. So I scanned Juice Shop version 17.1.1. It has an MIT license, and here's a unique package identifier I can use to identify this package. And then the component list. This is a very long list. There's dozens upon dozens, if not more, dependencies here. I'm just using this one example for now. So I know one of my dependencies for the Juice Shop is a library called VM2 version 3.9.17. It has the MIT license, and I have a unique identifier that I can use to identify this package. So my SBOM contains many, many components. I could kind of parse through them or read through them to kind of see what I'm dealing with here. So what does this mean right off the bat? Without doing anything else, without just by generating SBOMs, what does this give you? Well, you have an up-to-date list of software components, including versions and relationships. Not only do you know your top-level dependencies, those are pretty easy to get from a package.json file, but you also have a list of all your transitive dependencies and those dependencies and so on and so on. So the next time a big vulnerability comes out, take, for example, the log4j one that happened in December 2021, or Heartbleed way back from 2014, instead of looking through source code or build files or build artifacts, you could just reference your SBOMs to see how are you impacted by this or any versions impacted by this. You can write your own custom parsing tools as well. But you can do more. So the big use case with SBOMs is for vulnerability management. So let's see how you could do some quick vulnerability scans. So I'm going to use the VM2 example. So I know I have a package called VM2 version 3.9.17. Let's pass this to the OSV API. The OSV is an open source online vulnerability database. I believe it's hosted by Google. So I could just make a post request to this API. And what do I get back? Well, this library has vulnerabilities. I should probably look into that. Maybe I'm impacted by them. Maybe I'm not. Maybe I just need to update some versions. Maybe I could ignore it. Maybe it's drop everything and deal with this. Obviously, we don't want to do that vulnerability package by package, as there's hundreds upon hundreds of dependencies in your SBOM. So we could just pass our SBOM into this tool called OSV Scanner. So I'm just giving it my whole SBOM, and what it's going to output excuse the blurriness on that. But it's just, here's a table of all of the vulnerabilities in my juice shop. So it has a reference to their OSV URL, so I could click that to see more information about it. I have my CVSS score, the ecosystem, the package, and the version, and the source. So instead of doing this dependency by dependency, I could just pass it to a tool that gives it everything for me. The other big use case with SBOMs is, what about license compliance? So I like to say, just because it's open source doesn't mean it's free. Depending on what you're doing with your product, how you're selling it, how customers are installing it, there might be obligations for you to kind of give back to the community or publish your software as open source as well. So what if I want to just see what licenses am I using? So same tool, the OSV scanner, I could scan my SBOM, I could enable the license summary check, and then I get a table of all of the different licenses in my product. What if I have a list of approved licenses? So in this case, I want to allow BSD version 2, version 3, Apache 2.0, and a couple other ones. Tell me if I have any software that falls outside of this list of licenses, and the tool can give you that. So with your SBOM, you kind of find out if you're in or out of compliance with in terms of your licensing requirements. Like I said, this doesn't necessarily mean it's a red flag, but it's just something you should probably look at it and kind of see what's going on. And one of the last things I want to quickly show here is, what about verifying the quality of your SBOM? So I did mention earlier that the NTIA did come out with minimum elements. What if I want to test for those? SBOMs, after all, are meant to be shared. There's many tools that generate SBOMs. Some do really good jobs, some not so good. So I could use this tool here called SBOM QS to score my SBOM. I want to give it the category of NTIA minimum elements, and I'm just going to pass in my SBOM, and it's going to give me an output like this. So for my NTIA elements, everything scores a 10 out of 10. That's great, except component with suppliers. My SBOM doesn't contain any of that. So this is where a topic like SBOM enhancement comes in. That's a talk entirely on its own. But there's a lot of tools out there where once you generate an SBOM, you could enhance it with additional data to increase the quality of it. So this is great. I could do this on a regular basis, but what I really want to do is just automate this. I want to generate SBOMs either on every release or on every commit to the mainline branch, or maybe even on every pull request, depending on what use cases are. I don't want to manually have to generate all of these all the time. So I'm going to have a couple static demos here. I'm going to use Bitbucket, which is a product from Atlassian. So Bitbucket is very similar to GitHub, GitLab, or Azure DevOps, just an online Git-based solution. A Bitbucket pipeline, you could think of it kind of like a GitHub action. And a Bitbucket pipe is kind of a pre-configured pipeline that you could just drop into your CI and it'll run it for you. And to write a Bitbucket pipe, you're essentially just defining a Docker file and the entry point runs. And that's your Bitbucket pipe. So I have a couple quick static demos I'm going to go through. The first one is just how can you write something that just generates an SBOM as part of your CI pipeline. And the other one is, now that you have an SBOM, let's make it more advanced. Let's get some vulnerability information and quality information out of it. So like I said, the first example, Bitbucket pipe to generate an SBOM. So this is the Docker file for that, and at the end of this presentation, I will have links to GitHub where you could find all these examples and other links as well. But this is the entire Docker file, so it's pretty straightforward to just generate an SBOM. All I'm really doing, to summarize it, is I'm installing that CycloneDX npm tool that I demoed earlier onto a Docker image. I have a simple bash script that acts as a wrapper. That's going to be my entry point. Like I said, I will make the source code. The source code to this is available. I will put the links after this presentation. So very simple Docker file. To actually add this to my pipeline, Bitbucket pipelines just use YAML files, similar to a lot of other CI tools. So I have a couple different steps here. One is build and test. The other one is generate CycloneDX SBOM. I want to pass in my pipe. So all that's really doing here is just downloading this image from Docker Hub, version 1.5.0 of it. And then I'm just setting some environment variables that my wrapper script will grab and then make some decisions of. So I want my npm spec version to be 1.6. I want JSON output format. And there's a few other things. So what does this look like when it actually runs? So I have in my Bitbucket pipelines, I have my two stages that run. My build and test takes about 5 minutes. Generating the Cyclone DX SBOM takes only about 35 seconds. I have some output here. I can see what switches were used. And what this actually gives me at the end is I have artifacts and I have build artifacts I can download. So now I could download, Juice Shop version 17.1.1 cdx.json, and for however I want to configure it, like I said, every release is usually how I do it, but you could also do it on every commit to the mainline branch. You're generating an up-to-date SBOM. Now you could do other things with it. You could call it a day here, and at least you have it. You could archive these and keep them secure. You could share them publicly if you want, but at least your CI is generating it at every build. What about if we want to take it one step further? So what if we want to pull out some vulnerability information and we want to make sure our SBOM meets a certain level of quality before we share it or do anything else with it? So I have another example of a Docker file here. This one's a bit longer, so it's a few different slides, but it's basically I have a Golang wrapper. I have a Docker file that just installs a couple different tools. So in this case, OSV scanner and SBOM QS. My run commands actually do the installs, and I have my Go wrapper here that's called SBOM utils, that this will just run on the entry point. And based off what environment variables you give it, it'll make certain decisions. So to pass this into your pipeline, looks very similar to the one before. I have a step, scan SBOM with SBOM utilities pipe. I need to tell it where the pipe is, and in this case, it's in Docker Hub. I want to tell it, I need the path to the SBOM, so here's the path to the SBOM, and I need to tell it what to do. So I do want to scan with OSV, and I want my output format to be a table. I do want to scan it with SBOM QS, and I want my output format to be detailed, which in that tool it's a table, and just put all the output in my build directory and archive my build directory so I could download it after and take a closer look. So what this looks like when it runs, similar to before, I have my build and test step, I have my Gen Cyclone DX SBOM step, and I have my scan SBOM with SBOM utilities pipe. So this runs, I still get my build file, my output, so I have my juiceshop.json file, I have my SBOM QS results, and I have my OSV scan. So I could take a look at this every release, and there's much more advanced things you can do. So this is just the bare bones kind of scratch the surface basic. I just want my SBOM and I want my vulnerability reporting and SBOM QS reporting as part of my CI. But most of these tools give you more advanced capabilities, like what if I want to fail my pipeline if there's a high priority CVSS score? So if it's anything CVSS 9.0 or above, fail the pipeline. Or what if these vulnerabilities don't impact me? I did reachability analysis and none of them really impact me, or there's just no fixes available, or I just don't care about them. You could give these tools ignore files, so it'll only show vulnerabilities that you might actually want to take action on. So where to send all of these SBOMs, that again is another topic on its own. Actually, interesting enough, today there's a BSides conference in New York, and this is one of the topics, what to do with all these SBOMs. Couple things you could do with it, just there's different tools out there to kind of send your SBOMs to. So instead of writing everything from scratch, you could just host a server or send it to a SaaS service. So OS Dependency Track is a free and open source tool. You could stand that up, you could send your SBOMs to it, and it will give you more prettier graphs and more detailed information. Another one is Interlink SaaS. Interlink is it's a commercial provider, but they do have a free tier. And once again, you could send your SBOM to them via API, so your pipeline could do it, and you could get much more insight into kind of what's going on. So just conclusion and key takeaways here. So due to Executive Order 14028 and due to the European Cyber Resilience Act, there is widespread adoption of SBOMs. Industries and governments are mandating their usage, and even private companies as well. There's plenty of open source tools available to kind of build your own really cool solutions. This is just one example. So you don't necessarily have to spend thousands on commercial solutions. That's really how much they cost, especially if you're a smaller company. So like I said, the tools are out there. It's becoming more and more prevalent, and some neat stuff going on in that area. So I think that's everything I had. Right at 20 minutes. So yeah, thanks everyone. And I have The easiest way to contact me is just through email. It's up there, or just LinkedIn. Connect with me, reach out to me. I have some links to some sample projects. I will post the slides there as well, and I think the BSides also post the slides.
We have the slides, so
Perfect.
whatever you want us to do with them.
Yeah, cool. And then the very last slide here is just all the tools that I showed. Here's some links to them. So once you get the slides, feel free to take a look at these projects.
Great,
Thank you.
thank you. Thank you, Cosimo. Sorry, I was calling you Commisso, and then that's your last name.
Yeah.
So we have time for questions, and I think the checkered shirt.
We've been using Trevi to scan containers in Kubernetes
Yep.
pretty successfully, but I think you talked about management of issues. Have you found any tools that help deduplicate or track and like assign issues and give them out to different teams and the like? It's really the management problem.
The management part is tricky. We use one tool, Sneak, but it's not like it does its own thing, right? You can't really give it an SBOM. I know with the interlink tool, I believe that has a hook to Jira. If you're using Jira, I think it has hooks to other ticket management systems where you could do things like that. Yeah.
So I got a question for what happens if one of the dependencies falls outside what you want for it? If you detect a vulnerability or it falls outside, like they change the licensing, then what happens? You can only detect the SBOM will only detect it for you. How do you like prevent it?
It differs use case by use case. So if there's a vulnerability that's detected, it's, you should look at it to see, does it impact you, do reachability analysis, or maybe it just falls outside of your range if the CVSS score is too low. You can see if there's a fix available and update that. Different languages have different kind of rule sets. So for Node NPM projects, one thing we do pretty often, at least once a quarter, just run NPM audit fix. And it'll go in and just update a whole bunch of dependencies for us in a non-breaking fashion. So we're kind of kept up to date. It's hard to have zero vulnerabilities, especially with ecosystems like Node NPM or Python or Go. But really it differs based off of kind of your company and your rule set and how you want to manage that. You're welcome.
Yep. So if you're building and supporting this product, this would be the SBOM you would provide to customers or downstream. What's your SBOM going to look like if you're building and supporting a closed source product? Like let's say you're NVIDIA. What's your SBOM going to look like when you sell drivers?
It's a great question. I don't know if I have an answer to it. I focus more on the open source side of things. Closed source companies, I believe they would. I don't really know what they do. Yeah. Yeah. There's been a lot of talk about. Yeah. So I know there's been in a lot of groups, so there's been a lot of information about what do we redact from SBOMs? Like what do we just not want people to know? That's kind of a topic out there now. But yeah, on the closed source side, it's interesting because yes, NVIDIA is definitely using open source. Just what do they tell their customers?
And maybe their risk managers are working diligently on answering those questions.
Risk management, the vulnerability tools, they need a machine-readable vulnerability feed. Are they clear about where they're getting those?
Yeah. So the example I gave is the OSV API. They have a lot of just documentation on their website of kind of where they get their sources from. There's the Sonatype OSS index. There's a lot of other ones out there as well.
Because my management wants the type of thing that's updated once an hour.
Yeah. Yeah.
I don't have a question, but I have an answer to that guy's question. Like you asked about the tool, Weave and Flux had started doing that part, and you can explore those tools. I just use it. Weave and Flux CD. Weave and Flux CD. They are two different tools. Flux CD has I used it and it's more compatible.
Cool, thank you.
Yeah, you talked briefly about reachability analysis there. Can you talk about how you approach that and like what happens after you have these vulns? Like what's the process to remediate? Do you triage them on the security side? Do you give them to developers?
We definitely triage them. In a perfect world, there's just a fix available. Update to this version. A lot of times that's not the case, and then it's a case-by-case basis. How urgent is it? How vulnerable is it? Typically the big ones, like the Log4j's, the Heartbleed, there's a fix available right away. for the ones that aren't like that, it's just, risk that you need to be willing to deal with.
Yeah, but who does that? Security or developers?
It will differ company to company. I work at a small startup. We wear multiple hats, so a lot of times it's us. Bigger companies that have the red team, blue team mix, it might, it differs.
Yeah, and the reachability analysis, how do you do that?
There's tools out there. There's threat modeling. I think there's a couple presentations today about threat modeling. There's a lot of different tools and literature on it. There's many different approaches. I think it depends on your runtime and how your product is configured.
I think we have one more question here, and then we'll wrap up.
So, what are your thoughts on source-based distributions? In the matter of fact, they basically have SBOMs built into them. Source-based distributions.
Okay.
Linux distributions
Oh.
where you compile the source yourself, where you get access to the source code, you download it, and you build it.
What is my opinion on that?
Your thoughts?
I don't have a strong opinion on it. We all use Linux. I use Linux. I've never compiled my own version of it, but I don't have a strong opinion there.
But does it seem like a good idea for SBOM to basically be able to generate?
Yeah, it would be good to know what's in there, especially if you're, compiling Linux for an embedded system, something that goes into healthcare. Yeah, you definitely kind of want to know what's in there. It's definitely a good